Look here with me, Kareem. Here I have a large piece of iron. My question is, what will you get if you try to break this piece? Will it still large as it is?
Yes.
If you try to break this large piece, it will stay as it is as a large piece?
It will get smaller.
Very good. I will have a smaller piece from this iron. Okay, do you think these small pieces are the smallest part of the iron?
No.
Very good. What is smaller from this?
The atoms and molecules.
Excellent. You already revised it. Molecule is smaller from this small piece because molecule with molecule give me the small piece. And smaller from this molecule is, as you said before, atom. Very good. So the building unit of the large piece or from any material, the building unit is the
small piece.
Small piece? The building unit is the atom.
Yes.
Okay, so the atom is very important. It's responsible for anything for the material, for the test, for the color. Give me a second. As this atom is very important here, it's responsible for the color, for the test, for the touch, for anything for the material, we have to study the structure for this atom. So look here. We already learned before that the atom in general has two parts. Part inside and something moving around this. Do you remember what inside the atom? What's found in the center?
Yes, it's the nucleus.
Very good, nucleus. And what's moving around this nucleus?
They are electrons.
The electrons, very good. And do you think these electrons are moving in a random way or they have an organized and definite way?
They have a
definite way. These ways are called energy levels. Okay, so the street or the way that the electrons are moving on is called energy levels. Clear?
Yes, yeah.
Very good. Okay, again, in general, the atom have two parts, nucleus and electrons moving around. If we focused on or inside this nucleus, we will find that it's made up from two things, protons and neutrons. What is the charge of each one of them?
Protons are negative, and neutrons.
From its name, it's neutrons, so the charge is neutral.
Yes.
Okay, so it's not positive, it's not negative. Very good. It's neutral. But protons is not negative.
Protons, yes, they are positive.
They are positive. Proton, positive. Neutrons, neutral. Okay. Electrons is negative. Yeah. Here, as you can see, inside the nucleus, positive and neutral. And outside, there are negative, which is electrons. Okay. Do you think the numbers of protons and electrons are equal or there are difference between them? Number of protons and electrons.
Yes, they are equal.
They are equal. The number of protons that inside the nucleus are equal to the number of electrons that moving around. So that we can say that in general, the atom is positively charged or negatively charged or neutral. The atom.
The atom?
Yeah.
I think it's
You have positive inside, negative outside, and both of them are equal. So the atom will be
neutral.
Neutral, that's it. Because positive equals negative. If positive was more, then it's positively charged. If negative were more, then it's negatively charged. We will see something like this now. But in the rest or in this table, atom, number of electrons equal number of protons.
Okay.
For the first atom here, hydrogen. The red one is a proton and the yellow one is electron. How many protons for the hydrogen?
1.
And how many electrons?
1.
1. Still have the same number. For lithium here, 6. How many electrons?
3.
And how many protons?
3.
3. So we all agree that the number of protons has to equal the number of electrons. But it's not necessary that the number of neutrons equal to them. Okay? It's
okay.
Note. Sometimes the number of neutrons equal to the number of proton and electron, but sometimes it's not. Like in case of sodium. In case of sodium, number of neutrons doesn't equal the number of protons and electrons. Scientists here, yeah, Karim, decided to not say the number of protons inside the lithium atom equal to And instead of all of this, we can say simply atomic number. So if I told you that atomic number equals 6, you have to know that number of protons or the number of electrons for this atom equals 6.
Okay.
Okay, I used a very small or a short concept to mean all of this sentence. And by the same way, weight number. But here weight number equal to the number of proton plus number of electron, not only one. Note here, we said that the number of electrons or protons are called atomic number. That because we said that the number of protons equal to the number of electrons. So we don't have to use 2 concepts for each one of them. Did you understand this point?
Yes.
I can use only one concept because the number of protons equal to the number of electrons. So I can say it's called atomic number. Here,
okay.
For number of protons plus number of electrons, I can use weight number. Where can I write both of this number? Here, as you see. For calcium, this is the first atom here. I have atomic number, which is written blue, and weight number in the upper side. Okay, so the weight is always in the upper side, but atomic number in the lower side. For chlorine here, yeah, Karim, what is the atomic number?
The atomic number 17.
17, very good. What is the atomic weight? Oh, sorry, our weight number have the same meaning.
35.
35, yeah. For copper, what is the number of protons?
Number of protons, 29.
29, because it's equal to the number of electrons. Very good. Okay, for sodium, what is the weight number?
23.
23. For helium, what is the number of electrons?
2.
What?
2.
2. Yes. And for carbon, what is the weight number or the atomic weight?
12.
Very good. So it's clear. We write the atomic number blue or in the upper?
Below.
Blue. But the weight number in the upper side.
Okay.
I have here a schedule of some questions. You can get something like this in this curriculum too, because you have all of this again in this year. So here for the first element, carbon. Carbon has atomic number equal to 6 and mass number equal to 12. Now he wants the number of protons. It will equal what?
Number of electrons. So it equals
It will equal what?
6.
6, yes. Look here, and the atomic number is 6. And the atomic number is the number of protons, so it will equal 6. Okay, second question here. For sodium, sodium has, as you can see in the symbol here, in the symbol on the left, you have to look in the left here for the symbol. There are something blue and something in the outside. 11 and 23. So the atomic number will equal to what?
11.
11, that's it. Okay. Number 3, for magnesium, he wanted the number of electrons.
12.
What?
12.
12, yes. For chloride, he wants the mass number.
35.
Very good. Mass number is the same name of weight number and atomic weight. They all are the same. So it will be 35. It will equal what?
35.
35. Okay. Number of neutrons.
Number of neutrons.
Yeah. We said in general it will be what?
It will be the same of.
The same. Very good.
Yes. So it will be 17.
17. Very good, Yakarin. Okay. In general, number of neutrons equal to electrons and protons. If it accepts, he will not ask you about this.
Okay.